Hello, Matthews. In this video, we're going to cover the derivative of an inverse. So let's get started. Before we can talk about a derivative of an inverse, let's talk about what an inverse is. So inverse function is any kind of a function that undoes another function. So what do I mean by undoing it? What I mean is if elements in the domain of f of x, if I'm going to undo that, are going to become elements in the range of g of x. And vice versa, I can say elements in the range of f of x become elements in the domain of g of x. When that happens, I can say that f and g are inverses of one another. So what I mean by that is if f of x has this point a and b, and g of x is the inverse is going to contain the point b and a. So basically, we're swapping our x and y values, and those are called corresponding points. Graphically, what does that mean? So graphically, if f of x and g of x are inverses of one another, we know that the functions are reflected in the identity line. So let's say, for example, this is the graph of f of x, and this is the identity line y equal to x. Now, why we reflect in that line is because the definition of inverse is that x becomes y becomes x. So that's why we're reflecting in the identity line. So you can see that this graph of f of x is reflected in the identity line, which makes this the graph of the inverse. So that's how you can recognize it graphically. Algebraically, we look at composite functions. So if I do the composite of f of g of x, and that's the same as the composite g of f of x, and both of those composites equal x exactly, when that happens, f and g are considered to be inverses of one another. So let's just practice this. So in this table of values, I have function values for f of x and g of x. So first thing I want to do is look at x and f inverse. So I'm looking at these two right here because that's x and f of x. So if I'm looking at the inverse, all of my x values become my y values, and all of my y values become my x values. So that would be the coordinates swapping x and y for the inverse of f of x. Now let's look at x with g of x. So for the inverse, again, x and y are swapped. So the y values become the x values, and the x values become the new y values. Okay, so now that we've done that, let's try some examples using our table of values. So in my first example, I want to do f of g inverse of 0. So I want you to start on the very inside. So g inverse of 0. So I'm looking at when x is 0, what is the inverse of that? And I can see when x is 0, g of 0 is 1. So this becomes f of 1. And then f of 1 tells me, okay, when x is 1, what's my f value? And that is negative 1. Okay, for my next one, I'm going to do f inverse of f of negative 1. Start on the inside. So I'm going to look at f of negative 1. So I'm going to negative 1, and the f value or the y value that goes with that is 4. So now I'm looking at f inverse of 4. So f inverse of 4, you're going to go to 4, and here's f inverse, that's negative 1. Okay, let's try this next one here. So I'm going to do f inverse of g inverse of negative 1. Start on the inside. So g inverse of negative 1. So go to your table. Here's negative 1. Here's g inverse, which is 3. So this is f inverse of 3. So f inverse of 3. So go to 3. Oh, and there is no 3 value. So if there's no 3 value for that, I can't do f inverse of 3. So this actually does not exist. Not an x value of 3 to go with that. Okay, here starting in the inside, f inverse of 4. So f inverse of 4, go to your x value of 4. I can see that's a y value of negative 1. So I'm looking at g inverse of negative 1. And now I'm going to go to negative 1 right there, and g inverse of that is 3. So it's just a series of substitutions. So let's use this idea and let's come up with what the derivative of an inverse is. So if we have f of x being functions such that g of x is equal to the inverse, okay? So I have that g of x is equal to f inverse of x, which just means that f and g are inverses. So remember algebraically, I said to you if they are inverses, then I know that the compositions are the same. F of g of x is equal to g of f of x, which is equal to x. So I'm just going to take one part of that equation, f of g of x equals x, and I'm going to take the derivative of that. Okay, so if I want to do the derivative of this entire equation, let's look at what that looks like. So this is in general. So this is chain rule. So I'm going to do the derivative of the outside, keeping the inside the same, multiplied by the derivative of the inside. And then the derivative of x is just 1. So let's get g prime, because that's the derivative of the inverse. So g prime of x is equal to 1 over f prime of g of x. So just rearranging my equation. Now, what do I know about g of x? Well, I said that g of x was the same as f inverse. Okay, so g of x is the same as f inverse. So g of x prime is the same as this prime, which is just, when I take the prime, that's the first derivative. So g prime of x is the same as saying the derivative of f inverse of x. That is going to equal to 1 over f prime of g. And what did we say g was? We said g was f inverse of x. So this is the derivative of an inverse. So the derivative of f inverse of x is 1 over f prime of f inverse of x. So this is something that we definitely want to commit to memory, and we're going to use it throughout this lesson. Let's try some examples. So here I have f of x is equal to 4x minus 3, and f prime of 2 is equal to 4. I want to find the value of f inverse of 5 prime, which means derivative. Okay, so basically I want to find the derivative of f inverse of 5. Okay, so let's use our formula. So let me actually just move this down, and we're going to write out our formula because I don't want to forget our formula. So the derivative of f inverse of x is equal to 1 over f prime of f inverse of x. Okay, so let's plug all that in. So if I'm doing the derivative of f inverse of 5, I'm going to go 1 over f prime of f inverse of 5. Okay, so f inverse of 5. So this is a y value of f of x. So I want to know the x value of f that goes with it. Okay, so if I look over here, I know that f inverse of f. So to find that out, I'm going to go and I'm going to plug in 5 for my x value. So this is my y value of f. So I'm going to plug in a 5 here, and I want to solve for what my x value is. So I'm going to, I'll just do that over on the side here. So 5 equals 4x minus 3. Add 3 to both sides. Divide both sides by 4, x equals 2. So this is equal to 1 over f prime of 2. Okay, and f prime of 2 we're given in the question is 4. So I know that my answer is 1 over 4. So let's actually just look at what we did here. Okay, we have our original function, f of x is equal to 4x minus 3. And we know that this is the derivative. This is the slope. The slope is 4. So at one particular point for f of x, I know that my slope on this line is 4. So I know that the derivative is going to be 4. Now, what did we just find? We found that the derivative of f inverse of x was 1 over 4. So what this does is gives us a nice little conclusion that we can use in other questions. The slopes of inverses are reciprocals of one another. So the slope of f of x was 4. The slope of f inverse of x is 1 over 4. So we can store that away as a little shortcut to use. Let's try another example. Okay, so we have f of 3 equals 8, f prime of 3 equals 5. What is the slope of the tangent line to the corresponding point on f inverse of x? So what we have right now, f of 3 equals 8. So that means the point 3 and 8 is on f of x. So the corresponding point would be swap your x's and y's, and that would be the corresponding point for f inverse of x. So what I'm asking for is the derivative of that. So the derivative of f prime of 8. So that would be my corresponding point. So let's apply that into the formula. That's going to be 1 over f prime of f inverse of 8. Okay, and what is f inverse of 8? Well, I know that that is 3, because if this is my y value of f of x, the x value that goes with that is 3. So this is 1 over f prime of 3, and we know that f prime of 3, given in the question, is 5. So my final answer is 1 over 5. Okay, let's try another one here. We're going to fill in the table here. So we're given f of x values, f prime values, the derivative. We want to come up with g of x and g prime of x. And g of x is going to be the inverse of f of x. Okay, so g of x is the inverse of f of x. Okay, let's come up with the points first of all. So these are the points here for f of x. So the corresponding points for g of x are going to be 5 and 2. These points here, flip them around, -1 and 3. These points here, flip them around, 4 and 1. Okay, so looking at that, sorry, 4 and -1. Now I want to find g prime of x, which is, this again is the same as saying the derivative of the inverse. That's the same thing. Okay, so let's apply our formula. That's going to be 1 over f prime of f inverse of x. That's what we're going to do for every one of these. So this is going to be 1 over f prime of f inverse of, my value is 2. Okay, so if I want to do that, I'm going to do f inverse of, sorry, 5 is my x coordinate. The answer is 2. There we go. Okay, so this is going to be 1 over f prime of 2. And f prime of 2, I can go there and see that there's my x value. F prime of 2 is 0. So I'm going to have 1 over 0, which we know is undefined. So this one here does not exist. Okay, let's go to my next one. Okay, so for this one here, I'm going to go 1 over f prime, f inverse of x. The more times you write it out, the faster you can commit it to memory. Okay, so this is f prime of f inverse of -1, which we know is 1 over f prime of, the value that goes with that is 3. And f prime of 3, there's 3. F prime of 3 is -4. So it's 1 over -4, or I would prefer to write it as -1 over 4. Okay, let's look at our last one. So same idea. Okay, so I'm going to go 1 over f prime of f inverse of x. So it's going to be 1 over f prime of f inverse of, my x value is 4. Okay, the y value that goes with that, because I'm looking at the inverse, is going to be -1. Okay, so I'm going to go to -1 on my table. There it is. And there is f prime. So this is going to equal to 1 over the f prime, which is 6. So this answer here would be 1 over 6. Okay, let's try another one. For this one here, g is the inverse of f. I want to calculate g prime of -9 for this function here. Okay, so since g of x is the inverse, I know that g of x is the same as f inverse of x. So if I want to find g prime of 9, that's really asking me to find the derivative of f inverse at 9. Okay? Oh, it's -9. Whoops-a-daisy. Let's write that as a -9. Okay, so this is your y value. This is your y value for f of x. I want to find, to know that, what x value is of f of x that goes with that. Okay, so I'm going to have to do a little bit of work here. Okay, so here's my f of x. So this is -9 equals 4x cubed plus 5x. I'll add 9 to both sides. And then I have a polynomial that I need to factor. So I'm going to use synthetic division for this. So I know that the value of the polynomial at -1 is 0. Which means that I know that x plus 1 is a factor. So I'm going to use synthetic division and break this down. Okay, so I've got 4, no x squared, 5 for x, and then my constant value of 9. So I bring this down and I multiply and then subtract. I multiply and then subtract. I multiply and then subtract. So I know that this factors as x plus 1 times 4x squared minus 4x plus 9. Okay, so what does that tell me? The point that goes with that is my x plus 1 is my factor. It's actually at -1. So when y is equal to -9, the x value is equal to -1. So I know that this is going to equal to, let's do our formula. So 1 over f prime, f inverse of -9. So this is going to be 1 over f prime of -1. Now we have to do a little bit more work. We don't know what f prime is. So if f of x is this, I know taking the derivative, it's going to be 12x squared plus 5. And then I just put in -1 there. So f prime of -1 is going to be 12 times -1 squared plus 5, which is just 17. So this final answer, 1 over 17. Okay, last question, and it is a calculator question. Okay, so I want to find the derivative of f inverse of 3. So we're going to do the same process that we did on the last question, but we're going to use our calculator. This would be one of those calculator expected type questions. Okay, so to find the derivative, first thing is, remember this is your y value. For the function f, you want to find the x value that goes with it. Okay, so I'm going to go to my calculator to do that. Okay, so in my calculator here, I am going to enter in my equation. So that was 4x exponent 7, and then minus x squared plus x minus 5. And I want to know when that is equal to a y value of 3. So I'm going to calculate the intersection point. Okay, so 1, 2, 3, there is my intersection point. So I'm just going to take that out to my main screen and copy it over. Back over to my notes, I now know that the x value is approximately 1.106, but I'm not going to take it off my calculator. Okay, so this is saying 1 over f prime of that 1.106 number. So now I need to find the derivative of f. So if f is equal to this, f prime is 28x exponent 6 minus 2x plus 1. So what I'm going to do is take that x value and substitute it in here and here. Okay, so then this will be 1 over, it'll give me that answer. So back to my calculator. So I am going to go 28 times, I'll grab my x value, to the exponent of 6 minus 2 bracket, oh, hold on, got to get out of my exponent. Let me try that again. There we go. Okay, so then minus 2 times, go up and grab my x value, close my bracket, plus 1. Okay, and then I get that number. So back over here, that's 1 over 50.146, etc. And then all I have left to do is just divide that on my calculator. So over here, 1 divided by, go up and grab my number. And this will be my final answer, which we want to 4 decimal places. So the final answer would be, to 4 decimal places, 0.0199. So that is derivative of an inverse. Interesting twist on inverse. What about if we looked at the derivative or the inverse of converse? Maybe that's some food for thought. So I hope that this video helped. If it did, please give it a thumbs up and hit subscribe so I can help more mathies just like you. Thanks for watching, and I'll see you for the next one.